Hello everyone, thanks for attending my talk today. My name is Andrew Knight, but you can call me Pandy for short. I'm the Automation Panda. Check out my blog and follow me on Twitter. Just Google Automation Panda and I'm sure you'll find me. Currently, I'm a developer advocate at Applitools, where I help folks get the most value out of their QA work with automated visual testing. I'm also the director of Test Automation University, which offers several online courses to help you learn testing and automation. And it's completely free. Please check it out. It's awesome. Now, you might be wondering what an Automation Panda is doing at a machine learning conference. Well, I want to share one way that AI is making a huge difference in the software, testing, and automation space. And that's visual AI. Traditionally, automated tests focused on things like text and attributes to make sure apps were correct. Unfortunately, that would miss lots of problems. Visual AI can quickly flag visual differences that both scripts and manual testers might miss. I'm guessing most of you in the audience have done some form of testing before, even if it's as simple as making a small code change and rerunning your program. That's awesome. There are all kinds of testing: unit tests, integration tests, end-to-end tests, web UI, REST API, mobile, load testing, performance testing, property-based testing, behavior-driven, data-driven, you name it, there's a test for it. But what is testing in a nutshell? In simplest terms, testing is interaction plus verification. That's it. You do something and you make sure it works. Every kind of testing reduces to this formula. Manual testing accomplishes both interactions and verifications by direct human interaction. Somebody needs to bang on a keyboard to drive a test. Automation drives interactions and verifications with a script. We'd like to think that automation is so great because it doesn't need any human intervention, but we all know that's not true. Humans still need to write the tests, develop the scripts, and fix them when they break. Paradoxically, test automation isn't fully autonomous. Visual testing helps to change that. Although humans still need to figure out interactions, visual testing techniques make verifications autonomous. Teams take snapshots of their views and look for changes over time. They catch more kinds of problems while ironically simplifying test code. Unfortunately, many folks seem to have the impression that visual testing is an advanced technique that requires a high level of testing maturity to be valuable. That's not the case at all. In fact, I want to flip that script entirely. Visual testing is easier than traditional test automation. This isn't some bleeding edge technology useful only to FANG companies. It isn't out of reach for teams just starting their test automation journey. Visual testing makes functional testing easier and stronger. AI simplifies test development. It's something teams should do first before attempting to automate longer, more complicated tests with traditional techniques. Big claims, right? Let's see what I mean. We are going to automate a web test together in Java with Selenium WebDriver using traditional interactions and verifications. And then we will supercharge it with visual testing techniques using Applitools. First, we need a web app to test. We could test an app of any size, but I'm going to choose a small one for the sake of our demo. This is Applitools' demo site. It mimics a banking application. You can try it yourself at demo.applitools.com. The login page has a main icon, username and password fields, and a sign-in button. Since this is a demo site, you can enter any username and password to log in. After clicking the sign-in button, the main page loads. There's a lot of stuff on the main page. The top bar has the name of the app, a search field, and icons for your account. The main part of the page shows financial data. The left sidebar shows different account types. We could write a basic login test for this app in 4 steps. Load the login page, verify that the login page loads correctly, log into the app, and finally, verify that the main page loads correctly. This could be a smoke test. There's nothing fancy here. The trickiest part for automation would be deciding which elements to check on the loaded pages. We could automate this test in Java using Selenium WebDriver. Technically, we could automate it using any popular language and tool. Personally, right now, I really like Playwright in Python. But based on different reports I've seen, Java is still one of the most popular languages for test automation, and Selenium WebDriver remains the most popular browser automation tool. JavaScript, C#, Python, and Ruby are other popular languages for test automation, and Cypress is a very popular alternative to Selenium. In Java, we can write a JUnit test class named loginTest and create a test case method named login. This test case method calls 4 helper methods, one for each step. The first method, loadLoginPage, loads the demo app's login page in the browser. The second method, verifyLoginPage, verifies the appearance of 5 critical elements on the page: the logo, username field, password field, sign-in button, and the Remember Me checkbox. It waits for each of these elements to appear using a helper method named waitForAppearance. The third method, performLogin, enters a username and password, and then clicks the sign-in button. So far, so good. Nothing too bad. These are all typical WebDriver calls. The fourth method, verifyMainPage, is a doozy. Remember all the things on that page? Well, they'll need several assertions to verify. Some assertions merely check the appearance of elements. Others need to perform text matching. For example, to check the banner at the top that says your nearest branch closes in X minutes, we need to find the element, get its text, and then perform a regular expression match. Checking the account types and status fields require getting lists of elements, mapping their text values, and transforming the resulting data for comparisons. Despite this heavy lifting, this page still doesn't check everything on the main page. Dates, amounts, and descriptions are all ignored as a risk-based trade-off. We could add more assertions, but they would lengthen this method even more. They could also be difficult to write and become brittle over time. Tests just can't cover everything. If we run this login test against our app, it should pass without a problem. But what if the page changes? Here's a different version of the same page with some slight visual differences. Can you see what they are? Let me go back and forth a few times for you to see. Will our login test still work? Will it pass or fail? Should it pass or fail? Looking at these two pages side by side makes comparison easier. The logos are different, and the sign-in buttons are different. While I'd probably ask the developers about the sign-in button change, I'd categorically consider that the logo change is a bug. Unfortunately, as long as the page structure doesn't change, our login test will still pass. It wouldn't detect these changes. We probably wouldn't find out about these changes if we relied exclusively on traditional test automation. The step to verify that the login page loaded correctly only checks for the appearance of 5 elements by locators. These assertions will pass as long as these locators find elements somewhere on the page, regardless of where or how they appear or what they look like. Technically, this login page would still pass the test, even though we can clearly see it's broken. Traditional functional testing hinges on the most basic functionality of web pages. If it clicks, it works. It completely misses visuals. Those are huge test gaps. Adding more assertions probably won't catch these kinds of problems either. So what if we could visually inspect this page? That would easily catch any changes on the page. We'd take a baseline snapshot that we consider good, and every time we run our tests, we take a new checkpoint snapshot. Then we can compare the two side by side to detect any differences or any changes. This is what we call visual testing. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. Automated visual testing is what tools like Apple Tools does. One visual snapshot captures everything on the page. As a tester, you don't need to explicitly state what to check. A snapshot implicitly covers layout, color, size, shape, and styling. That's a huge advantage over traditional functional test automation. To be honest, testers have been doing visual testing since computers first had screens. Anyone can manually bang on a keyboard and look at the screen to see what changes. That's arguably the first kind of testing that anyone does. It's super valuable to take a quick glance at a page to see what's wrong. Humans can intuitively judge if a page is good or bad in a few seconds. Unfortunately, human reviews don't scale well. Modern apps have several screens worth checking, and continuous integration systems deploy changes multiple times a day. Humans make mistakes. They get tired. They miss things. They also have a limited time. This reminds me of the legend of John Henry, a folk hero from the United States. As the legend goes, John Henry was a railroad worker on the Great Bend Tunnel along the C&O Railway in West Virginia. When the company bought a steam drill, John Henry competed against it head-to-head with a 10-pound hammer in each hand to see which could drill faster. John Henry drilled deeper than the steam engine could, technically winning the contest, but he died from exhaustion afterwards. The legend of John Henry serves as a parable that even the strongest, sharpest human is inevitably no match for a machine. To be relevant in a modern software shop, visual testing must be automated. But that's easier said than done. Programming a tool to capture snapshots and perform pixel-to-pixel comparisons isn't too difficult, but determining if those changes matter is. A good visual testing tool should ignore changes that don't matter, like small padding differences, and focus on the changes that do matter. Otherwise, human testers will need to review every single result, nullifying any benefit of automating visual tests. Take a look at these two pictures. They show a cute underwater scene with an octopus in a garden. There are a total of 10 differences between these two pictures. Can you find them? I'll give you a few seconds to look. Unfortunately, a pure pixel-to-pixel comparison won't find any of the changes. I ran these two pictures through AppleTools using an exact pixel-to-pixel comparison, and this is what happened. Except for the white space on the sides, every pixel was flagged as different. As humans, we can clearly see that these images are very similar, but because they were a few pixels off on the side, automation failed to pinpoint meaningful differences. This is where AI really helps. AppleTools uses visual AI to detect meaningful changes that humans would see and ignore inconsequential differences that just make noise. Here, I use AppleTools' strict comparison, which pinpointed each of the 10 differences. Take a look. Did you find all 10 yourself? Do you see any that you missed? I'll pause a moment for y'all to look. That's the second advantage of good automated visual testing. Visual AI, like what AppleTools does, focuses on meaningful changes to avoid noise. Visual test results shouldn't waste testers' time over small pixel shifts or things a human wouldn't even notice. They should highlight what matters, like missing elements, different colors, or skewed layouts. Visual AI is a differentiator for visual testing tools. Pixel-to-pixel comparisons are inherently fragile. Visual AI makes visual testing robust and practical. So, let's update our login test to do visual testing with AppleTools. First, we need to create an AppleTools account. Anyone can create one for free at the link I'm showing here. You can use your GitHub account or an email, and you don't even need a credit card. The account will come with an API key that must be set as an environment variable for testing. Next, we need to add the AppleTools Eyes SDK to our project. Since we are using Selenium WebDriver with Java, we need to add the com.appletools.eyes Selenium Java 3 Maven dependency to our POM file. Then we need to set up the AppleTools configuration and runner for all tests in a suite. The visual grid runner will upload snapshots to Applitools Ultrafast Grid, and the configuration object sets the API key, the test batch name, and the browser configurations we want to test. This snippet shows configuration for Chrome, but we could test any other browser, like Safari, Firefox, or Edge, for genuine cross-browser testing. The setup for each individual test still needs a WebDriver object, but it also needs an eyes object for capturing snapshots. Here, we construct the eyes object, hook it up to the runner, and set its configuration. Then we open our eyes to start taking snapshots. Opening requires the WebDriver reference, the app name, and the test name. The interaction methods can remain unchanged, but we need to update the verification methods. Traditional assertions can be completely replaced by one-line snapshot calls. Take a look at load login page. 5 lines reduced to 1, and the visual snapshot technically has far greater coverage. The impact on verify main page is far greater. One visual snapshot eliminates the need for several lines of assertions. This is the third major advantage visual testing has over traditional functional testing. Visual snapshots greatly simplify assertions. Instead of spending hours deciding what to check, figuring out locators, and writing transformation logic, you can make one concise snapshot call and be done. As an engineer myself, I cannot understate the cognitive load this removes from the automation coding process. I said it before and I'll say it again. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. So, let's see visual testing in action. It's time to dive into code and run it. All right, so here is that Java project I mentioned. I have it opened in IntelliJ IDEA. And the visual test JUnit class has all visual testing code that I just showed you. Just to show you again, we have our setup before the entire test suite that creates our runner and our configuration. We have it configured to run against one browser, a Chrome browser with 800 by 600 viewport. We see we're using Chrome driver. We're setting up our eyes with our configuration, opening the eyes. Test case has 4 steps: loading the login page, verifying it, performing login, then verifying the main page. At the end, we quit. And then we have the code for our interactions and verifications. So let's run this test to establish baseline snapshots. I already have it configured, so I'm just going to hit the run button. And now IntelliJ IDEA will run our test. It should take only about a minute. So right now it's running it locally. Now it's going to upload the snapshot to Applitools Ultrafast Grid. And if I switch over to the dashboard, right now it's empty. If I refresh, we can see that that test batch is now there. It has the name of the batch we gave it. And after, let's see, after 17 seconds, it captured both snapshots and it's marked them as new, green for passing. So we can see these are our new baselines. So we have a baseline for the login page, and we have a baseline for the main page. So now let's run that test again. On the second run, since it has baselines, what the visual testing comparison will do is it will capture a new snapshot and treat it as a checkpoint and compare against the baseline using visual AI to see if there's any differences. So let's run again. Again, it'll take just a moment here, running locally. Now running in the dashboard. If we refresh the dashboard, we can see it's there, it's running. And it passed. So if we look at the checkpoints, we can see baseline versus checkpoint image, and they're the same, so nothing is highlighted differently. Same goes for that main page. Everything's the same, everything checks out. But now what happens if we introduce a visual difference like we saw before? So I'm going to run the test again, but this time I'm going to use that alternative login page, and we'll see what happens here. So we'll give it a minute. I just launched it again. It's running locally. And now it should be uploading to the grid. So if I refresh, we can see there's the new batch and it's running. Give it just a few seconds. And this time we have a problem. So the results show here. The main page didn't have any significant changes, so it's still green, but the login page certainly did, and so it's marked yellow as unresolved. What that status means, unresolved, is that Applitools has detected a visual difference, and it's up to you as the tester to determine if that was a good change or a bad change. So when we pull up the side-by-side, we can see all the things that were highlighted different. We see the icon was different, we see the sign in versus login button was different, and we see that the remember me check mark has shifted. So I'm going to say that this is a bad difference, and I'm going to give it a thumbs down. And what that does now is it will mark this particular snapshot as failed. So we save our changes. And what's really cool now is that if we were to run this test again, which I'll do here, I'll just click the run and we'll wait for it. What should happen is that since we've already marked that kind of visual change as a failure, anytime that visual checkpoint appears again, Applitools should automatically mark it as a failure rather than us needing to come in here and repeatedly fail it. So we run again, and there it goes. And automatically look at that. Because it was the same type of failure, Applitools was smart enough to know, boom, failed. So there's another really cool thing we can do with these visual snapshots. Let me jump back in the code. Look at the browser configurations. Previously, I only had one browser configured. But with Applitools, if you test in the ultrafast grid, you can actually test against multiple browsers. How is this possible? It's the magic of a snapshot. So I've been careful to say snapshot and not screenshot. A snapshot captures everything on the page in the DOM, the HTML, the CSS, and the JavaScript. A screenshot is nothing more than a collection of pixels, which it's static and doesn't change. But if you have a snapshot with all the stuff on the page, what you could do is you could re-render that on any browser configuration that you like. So even though you captured the page, let's say on Chrome, you could re-render that snapshot on Safari, on Firefox, on IE, or maybe even on mobile browsers, which is really, really cool. So let's do that. We'll get rid of our one browser configuration, and I'll bring these back to the forefront. So here now, we have 5 different desktop browser configurations: Chrome, Firefox, IE, Edge, Safari, as well as 5 mobile emulated devices: iPhone, X, Pixel, Galaxy, Nexus, and even an iPad. Each one has a different viewport size, as well as a different orientation. What's really cool about this is you can test browsers and devices that aren't on your local machine. For example, I'm running on a Mac, so I'm not going to have IE11 here, but I could run these tests visually against IE11 in the Applitools test cloud. Really awesome stuff. So let's run this again just to see what happens. I'm going to run it back on the original working website. So we'll kick it off, and then let's flip over to the dashboard again, and we'll wait for results here. When we do this, even though we specified 10 browsers, it will still only run one browser on our local machine, which we decided was Chrome. And it'll take that snapshot, and here we go. You can see how it's testing all those checkpoints against the different browser configurations. Chrome, IE, Firefox, Edge, Safari. And it's doing it concurrently. I, in my code, have set a concurrency level of 5, meaning 5 checkpoints can run in parallel. And already we're seeing, so the first one is marked as passed because that was the previous configuration that we had. But all the others should be marked as new because they would be new baseline images. And there we go, everything passed. This is a really, really cool way to not only do visual testing, but also to achieve cross-browser testing. You run the test once on your machine or in a CI server, and then you leave the rest up to AppleTools Test Cloud to render it against all the different browser configurations. This is much, much faster than traditional cross-browser testing, where you would need to run the entire test from start to finish, however many times you want for the different browser configs. If we look here, these 10 tests finished in only 46 seconds. Typically, a web UI test would take about half a minute to a minute to run. 10 tests, you're talking several minutes. Here, we're sub-minute, 46 seconds. Really, really cool stuff. Lightning-fast cross-browser testing is visual testing's fourth big advantage. To do cross-browser testing with traditional functional tests, each test must run on each browser configuration all the way through. With visual snapshots, each test runs only one time, and snapshots are re-rendered on each target configuration, making tests faster and more reliable. Before I conclude this talk, there's one more thing I want y'all to consider. When a team should adopt visual testing. I can't tell you how many times folks have told me, Andy, that visual testing thing looks so cool and so helpful, but I don't think my team will ever get there. We're just getting started, and we're new to automation. And automation is so hard, and I don't think we'll ever be mature enough to use a tool like AppleTools. I just smacked myself in the face because visual testing makes automation easier. I really think teams should do visual testing from the start. Consider this strategy. Start by automating a smoke test that navigates to different pages of an app and captures snapshots of each. The interaction code would be straightforward, and the snapshots are just one-liners. That would provide an immense amount of value for relatively little automation work. It's the 80-20 rule. 80% of the value for 20% of the work. Then, later, when a team has more time or more maturity, they can expand the automation project with larger tests that use both traditional and visual assertions. Let the power of AI help you. Test automation is hard, no matter what tool or language you use. Teams struggle to automate tests in time and to keep them running. Visual testing simplifies implementation and execution while catching more problems. It offers the advantage of making functional testing easier. It's not a technique only for those on the bleeding edge. It's here today, and it's accessible to anyone doing test automation. You don't need to be an expert in AI or ML to use it. Visual testing is a winning strategy. It has several advantages over traditional functional testing. Please note, however, that visual testing does not replace functional testing. Instead, it supercharges it. If you want to give it a try, you can sign up for a free account with AppleTools, clone the example project I showed today, or any of our others, and run tests on your local machine. Thank you all for attending my talk today on visual testing. Again, my name is Pandy, and I'm the Automation Panda, developer advocate at AppleTools and director of Test Automation University. Be sure to read my blog and follow me on Twitter. I always love to chat about testing and automation. So thanks again, and enjoy the rest of Conf42.